Section 22.6 Applications of Electromagnetic Induction to the Reproduction of Sound. So it turns out electromagnetic induction has a lot of applications beyond just cooking, and some of those are sound. So an electric guitar is one example of this. An electric guitar has these vibrating strings, but instead of having the big acoustic body that creates resonance and allows the vibrations of the strings to be heard elsewhere, the electric guitar has pickups. And the way the pickup works is it's a permanent magnet with a coil wrapped around it, and that coil goes to the amplifier. The guitar string is magnetizable, so if it passes near a permanent magnet, it will become magnetized north and south. So when you then pluck the string and it vibrates up and down, it goes closer and farther from this coil. As a result, there's a change in magnetic flux because the field strength varies as it gets closer and further from the coil. The coil then gets an induced EMF and an induced current, and that current is picked up by the amplifier, so it can recreate the sound of the vibrating string with really great precision. It's amazing how these work. There's so much more detail than I'm even able to cover, but if you talk to a sound person, they can cover a ton. Another example of this is microphones. So if you have someone singing into a microphone, like this woman here, looks sort of like Taylor Swift, we could imagine that. Then as the sound impacts the diaphragm, right, the diaphragm, it vibrates back and forth with the sound wave. Well, that diaphragm, it has a coil wrapped around it that moves back and forth in response to the sound wave. And that's moving over a stationary bar magnet. Guess what? If we're moving over a bar magnet, we now have a changing magnetic flux. Changing magnetic flux means we can induce a current in that coil that's wrapped around. And that current goes to an amplifier and can be reproduced as sound that is much, much louder and easier for everyone to hear. So these ideas are all around you. They're incredibly useful. It's not just some obscure thing. It's physics at work, all around. Pretty cool.